Dear student, this is class number 5 on the chapter Differential Equations. And in this chapter, we will learn how to solve exact differential equations. And to do this, let us start our session. Uh, First of all, we need to know what is an exact differential equation. So if you have given a function that is uxy and that is a constant, but it is continuous along with its first order partial derivative. So first, suppose that you have given a function uxy, and this is continuous, and not only this is continuous, but also its first order partial derivatives are also continuous, and then the total or partial derivative or differentiation of uxy is given by, you know, that du can be written as del u del x dx, where u is change only with respect to x, and then del u del y dy. In this case, x is constant but u is changed with respect to y. So du can be written as del u del x into dx plus del u del y into dy, that is equal to 0. This is equation number 1. Now this equation can be written as like equation number 2, that is du is equal to m is a function of xy, then dx plus n function of xy, then dy, that is equal to 0, where mxy is equal to del u del x and n xy is equal to del u del y. So this, since uxy uh, has continuous first order derivatives, so as in the definition in the beginning of this session, we stated that we stated that uxy is continuous, and also its first order derivatives are also continuous. So from here we can write del 2u by del y del x, that is partial derivatives, and you can write this as del 2u by del x del y. You know that from the knowledge of partial derivatives, that del 2u by del y del x is equal to del 2u by del x del y, and that is from here del 2u by del y del x can be calculated from here, since del u del x is equal to m, so del 2u del y del x is equal to del m by del y. Similarly, del 2u by del x del y is equal to del n del x. So this is the necessary and required condition for equation. This is equation number 2 to be an exact differential equation. So how to check or test whether a given equation is exact or not? First, we have to write the given equation in the form m dx plus n dy. Then just calculate del m by del y and del n by del x. If these two values are equal, then the given equation should be an exact differential equation. So the necessary and required condition is that del m by del y is equal to del n by del x. And under this condition, the solution of the differential equation will be of the form. So under this condition, if you solve the equation, then you will have the solution for u function of xy, that is equal to constant. So if you solve the problem, then you find out u in such a way that it will be a constant. Now this method involves two parts. Number one is to find out the solution. You have to integrate this m with respect to x. So to first you have to test whether it is exact or not, and the condition is del m by del y is del n. Once it is an exact differential equation, then you have to integrate this m with respect to x, and in this case keeping y is equal to constant. This is the first part, and the second part is integrate this n, but be careful that in this case all the terms involving x will be excluded. That means that for the second part, the, the quantities which are of which has no x terms, that is excluding of x terms, that is those terms which has only y component, y only y, involve only y, those terms in this case will be integrated with respect to x, and then sum these two or add these two integrations, and that will be a constant. So just recapitulate, or just remember that first we have to integrate this m with respect to x keeping y is constant, and number two is integrate those terms which have not involved with terms of x, that is the terms, only those terms which are involving with y, which are coming out from the variable y, or should be integrated, and these two terms should be then added, and this will give you the solution for u, that should be a constant. So sometimes note here note important thing, most important thing, that is sometimes equation like mdx plus ndy may not be exact, and in that case multiplying this equation with a factor makes it exact differential equation, and that factor, say that factor is fxy, that is another function of xy, and that is called the integrating factor. So suppose that you have given a differential equation and you have tested that it is not an exact differential equation, then you can make it exact differential equation by multiplying this type of equation by a function fxy, and then the term or the factor fxy is called the integrating factor. Here is an example for this. Let us suppose that you have given a function y dx minus x dy that is equal to 0. And if you compare this equation with the equation m dx plus n dy, you can easily understand that m is equal to y and n is equal to minus x. So from here, del m by del y is equal to 1 and del n by del x is equal to minus 1. So in this case, del m by del y not is equal to del n by del x. So the given differential equation that is written here is not an exact differential equation, and however this can be made exact by multiplying both sides of this equation, that is this equation, by the term 1 by y, 1 by the factor 1 by y square, and if you multiply both sides of this equation by 1 by y square, then equation 1 provides you from the first term 1 by y dx, then minus x by y square dy, and this term can be written as d dx of x by y. Just differentiate this, you will get this term, so that is equal to 0, or from here d of xy is equal to 0. Now integrate this equation, both sides of this equation, you will have x by y is equal to constant, so is the integrating constant, so x is equal to cy. Therefore an inexact or differential equation can make exact by multiplying it by the integrating factor, and then can be solved easily. And the integrating factors we learn to know that in case of homogeneous equation, or it may be non-homogeneous linear equation, we know that the integrating factor can also be find out in this by e to the power integration p dx, where you know that px is a function of x. So this type of this expression was used in case of linear homogeneous equation or non-homogeneous equation, which has the form this dy by dx plus pxy, that is equal to qx, this. But in case of exact differential equation, we will use this method, and if it is not an exact equation, then we should multiply by a suitable function that may make the given equation to an exact differential equation. After that, we can solve this equation. Now we will go through some examples. Number 1 is here. Solve the following differential equation: 4x cubed plus 6xy plus y squared dy by dx, that is equal to minus 3x squared 2xy plus 2. So the given equation is here. uh, it is written once again here, and just rewrite this equation in this fashion, that is 4x cubed plus 6xy plus y square, then dy plus 3xy 3x square plus 2xy plus 2 dx is equal to 0. Now compare this equation with this equation m dy, m dx, sorry, it should be m dx plus n dy, that is equal to 0. That will provide you that m is equal to 4x cube. This just this equation, this is the this equation can be written in this way, and this you can just compare with the general equation, that is this m dx plus n dy, sorry, m dx plus n dy. So from here you can easily understand that this, if you write this in m dx plus n dy, this would be x, so that is equal to here, from here you can write that you can write from here that m dy and m dy, that is m is here 3x square plus 2xy plus 2. So from here del m by del y, you need to prove it that if it should be an exact differential equation if del m by del y is equal to del n by del x. So from here del m by del y is equal to 4x cube plus 6xy plus y square, del y up, that is 6x plus 2y, and similarly del n by del x is equal to uh, this is here del x of 3x square and then plus 2xy plus 2, that is equal to 6 plus 6x plus 2y. So del m is equal to del my is equal to del nx. The given equation is therefore exact one, and if it is a exact one dimensional equation, you have to integrate am with respect to x, keeping y is constant, and then integrate uh, those terms which involves only y, but excluded from the term involving x. So first integration m dx, that is equal to, here is that 4x cube plus 6xy plus y square dx, that is equal to just integrate x to the 4 3x square y square x, and also the term which has which has free form x in the expression of n, that is only, see here that that was only 2y, just here, see here, it is 2y, that is only here 2, only 2, it is free form y, so you can write this as 2 dy, that is 2y. So the solution is given by therefore you have m dx, integration m dx was this, and 2 dy is equal to 2y, so just add these two terms, that is this and this, that will give you the solution, that is x to the 4 plus 3x square y square x plus 2y is equal to constant, because you are integrating this term and this term. So, and you know this type of equation has the solution, the exact equation has the solution of integration m dx and integration of this term which has free form x, that is terms involving only y, and add this and that should be a constant. So this is here. Now another problem is here 5x4 plus 3x square minus 3x square minus 2xy cube dx plus 2x cube y minus 3x square minus 5y to the 4 dy is equal to 0. This given equation can be written as m dx plus n dy, where m is equal to this 5x to the 4 plus 3x square y square minus 2x y cube, and n is equal to 2x cube y square minus 3x square y square minus 5y4. So from here del m by del y, just calculate del m by del y, that means you have to differentiate this expression with respect to y, that will give you for this term will be 0, from the second term 6x square y, and from here minus 6x y square, and after that you have to calculate del n by del x. From here n is given here, so that will provide you del n by del x is equal to 6x square y 6x square and y square. So this will provide you del m by del y is equal to 6x y, okay, no problem, then minus, okay, 6x y square, okay, and from here if you integrate with this, differentiate this with respect to x, that will give you 6x square, then from here y square minus 6 x y square. Okay, this is here. So only term is that 6x square, the first one is 6x, so 2x cube y. So sorry, here 2x cube y is here, so it is mistakenly written as y square, so it should be only y. So from here 6x square y first term is okay. Just differentiate this should be, here is mistakenly written y square, but it should be 2x cube y. So it should be 2x cube y, and if you differentiate it with respect to x, that will give you 6x square y, and this term will give you minus 6xy square. So here from here del m by del y is equal to del n by del x. So they are different, the given equation therefore an exact one. So if it is an exact one, then you have to integrate this m with respect to x. So that is m dx, that is equal to 5x to the 4 plus 3x square y square minus 2xy cube dx. Just integrate, this term will give you 5 into x to the 5 by 5 plus 3, then x square will give you x cube by 3, and then y square, after that minus 2, then this x will give you x square by 2 and y cube. So just simplify this, x to the 5 x cube y square minus x square y cube. And now also integrate the terms which are free from x of the equation capital N, that is this, which are free from x. So the term which are free from x only is 5y to the 4, so minus 5y to the 4. So differentiate it with respect to y, minus 5y to the 4 dy, this integration should be there should be dy, so that will give you minus y to the 5. So the solution is x to the power 5 plus x cube y square minus x square y cube and minus this y cube y 5, so that is equal to c. It is a constant, so you know that the addition should be constant. The next one is solve the differential equation 8y minus y x square y dy by dx plus x minus xy square is equal to 0. The given equation, that is this, the equation is written once again, and this can be written as 8y minus x square y dy plus x square x minus xy square dx, that is equal to 0. And this can be written as n dy plus m dx, where n is equal to 8y minus x square y and m is equal to x minus xy square from here. So del m by del y, that is equal to this from here minus 2xy, that is y square, so that will give you minus 2xy. And since n is equal to this, so del n by del x is equal, also can be calculated from here, that is also minus 2xy. So in this case del m by del y is equal to del n by del x. Hence the given equation is exact differential equation, and to solve this you have to integrate this m with respect to x, so keeping y as constant. So integration m dx is equal to x minus xy square dx. So first term will give you x square by 2, and the second term is x square y square by 2 with a minus is there, so half x square minus y square. And integrating those terms which are free from y in n with respect to y, that will give you, so n is here 8y minus x square, so this term is free from x, so 8y should be integrated, 8y dy, that is equal to 8 into y square by 2, that is 4y square. So now add these two terms, this term on this term, and equal the and equate this addition with a constant, that is done here. So x square minus y square 8y square, and that is equal to c, just c. So this is the solution. Another one is here, solve the following differential equation 2x ln log x dy dx plus y is equal to 0. This equation is here 2x ln x dy by dx plus y is equal to 0, or from here we can write 2x log x dy plus y dx, that is equal to 0. And this can be written as m dx plus n dy, where m is equal to y and n is equal to 2x log x. So now del m by del y from here is equal to 1, and del n by del x from here, that is equal to 2x, then x is 1 by x 2. So in this case, del m by del y is equal to 1 and del n by del x is equal to 2. So since these two the values of these two terms, that is del m by del y and del n by del x, are not equal, these are unequal, then the given equation, that is this differential equation, is not exact. Now you can make it an exact equation by multiplying both sides of this equation by y by this term y by x. Just multiply both sides of this equation by y by x. So that will give you y square by x. Then y square, just multiply this term with y by x, that will give you y square by x, and dx is multiplied with this. So y square by x dx, then plus 2 y, then log x dy. This x will be cancelled out with this x. So the 2y ln x log x dy is equal to 0. And this equation exact, that can be proved in the following way, that here you just compare it with the equation m dx plus n dy. So m is equal to here m is equal to y square by x, and n is equal to 2y log x. So just differentiate this m, del m by del y with respect to y, that is equal to del y of, from here, y square by x, that is equal to 2y by x. And then differentiate this from here, del n by del x, that is del x of, in this case, n is equal to 2y ln x log x, that is equal to 2y, and log x, differentiation of log x is 1 by x. So these two terms are equal. So in this way, if you multiply this equation by the given equation by y by x, then if you multiply the equation number 1, that is here, this, if you multiply this equation by y by x, then the equation will reduce to uh, an exact equation. So now to solve, you have to integrate m with respect to x, keeping y is equal to constant, that is equal to here y square by x dx, that is equal to y square log x. Now the integration of the the terms which are free from x of in the expression of n with respect to y. So you see here, here n is 2y log x. So in this case, no terms in are involving without x. So you can consider that as 0. So that is 0 into dy, that will give you constant c1. So add these two, that should be another constant. So y square log x plus c1 is equal to constant, or y square log x is equal to c, where c is equal to this c2 minus c1. Okay. Now another problem is here, show whether the equations of phi are exact differential. Just you have to test whether these are exact or not in exact differential equation. First one is d phi is equal to x square plus y dx plus x dy, and the second one is this. First one, just here, right here, d phi is equal to x square plus y dx plus xy. So this has the form m dx plus n dy, where m is equal to x square y and n is equal to x. So del m by del y, from here you can easily calculate, that is 1, and from here del n by del x is equal to 1. So these two values are since equal, so d phi is a exact differential equation, and you can solve this as usual method that is shown here. Okay. And then next one is, you have to test whether this d phi is equal to x cube minus 4xy dx plus y square minus 2x dy is an exact one or not. So this equation is written here also once again. The given equation is x cube minus 4xy dx plus y square minus 2x dy. So this can be written as m dx plus n dy, where m is equal to x cube minus 4xy and n is equal to y square minus 2x. And from here, del m by del y is equal to minus 4x, and del n by del x is equal to minus 2. So this del m by del y and del n by del x are not equal. So from this you can easily conclude that d phi is not an exact differential equation. So this is all about the exact differential equations. So you have to first test or check whether the given equation is an exact one or not. If it is an exact differential equation, then you have to solve this, and you have to first integrate m with respect to x, keeping y is constant, and then you have also to integrate those terms involving only y, not x, in the expression of n with respect to y, and then you should add these two terms and make them a constant. That will be the solution of an exact differential equation. And if the given equation is not an exact one, then you have to multiply the given equation with a suitable function that is called the integrating factor, and after that you can make the given equation that is inexact differential equation to uh, an exact differential equation, and then you can solve it in by usual method. So this is the end of this class.